Now, throwing yourself out of a plane may not be your idea of fun, but if it's all in the name of science, at number 15, falling bodies. Science is always evolving. About 2,000 years ago, this guy here, Aristotle, said that the rate of acceleration with which a body falls to the ground depends on its mass. Look at these bodies falling. Why have some accelerated to a greater speed than others? If Aristotle was right, and acceleration depends on mass, this would mean that a heavier body would drop to the ground at a different acceleration than a lighter body.
So, let's give it a try.
At ground level, we have Jessica, with a camera to record the exact point when the ball hits the ground.
Hello, girls. Right, to the left we have a cricket ball, and that's 3 times greater mass than a tennis ball. So let's drop them at the same time and see what happens. Okay, you ready? 3, 2, 1, drop! How did it look, Jessica?
They look like they've dropped at the same time.
Wicked.
Looking at Jessica's footage, it looks like the balls do indeed hit the ground at the same time, even though the cricket ball is 3 times heavier than a tennis ball. So our experiment shows that Aristotle was wrong. The balls drop at the same rate regardless of their mass. The first person to point this out was Galileo, who, according to legend, did the same experiment from the Tower of Pisa 500 years ago.
So if the balls landed at the same time, the same should be true of a hammer and a feather, right? Well, let's give it a shot. 3, 2, 1. What happened there?
Air resistance affects the feather, that's why it falls less quickly.
That's right, it is air resistance.
Air resistance is stopping the feather from falling to the ground at the same rate as the hammer. Remember our skydivers? They're able to change their rate of acceleration by making themselves more or less streamlined. If we remove the effect of air resistance, all falling bodies should fall at the same rate, regardless of their mass.
So let's go to a place where we can try this experiment with no air resistance. Does anyone know a good place where we could do that?
Space.
Yes, a vacuum in space.
During the 4th moon landing, Galileo's theory was put to the test.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And I'll drop the 2 of them here and hopefully they'll hit the ground at the same time. How about that? That proves that Mr. Galileo was correct in his findings.
The feather and the hammer land at the same time. Unlike Earth, the moon has no atmosphere, so there's no air resistance to interfere with the experiment. The moon's gravity causes them to fall with the same acceleration, even though they have very different masses. It's a shame Galileo wasn't around to see that. And for my next trick, I will make money disappear. Easier than it looks. Number 14, total internal